Next point is distance of point from line. So find the distance of point -1 to 5 from the line through 3, 4, 5, and having direction ratio cosines are proportional to 2 minus 3, 6. That is, we are given the direction ratios. We are given the direction ratios and the one point on the line. So we can write the equation of line. What is it? The equation of line passing through this point and having direction ratios. We write the equation in this form, that x minus 3 by 2, that is the a, and y minus 4 divided by minus 3, and z minus 5 divided by 6. So this is the equation of the line passing through this point and having direction cosines proportional to this, means we have the having the direction ratios 2 minus 3, 6. So the same question, that is find the distance of this point from this line. Find the distance of the point -1 to 5 from the line, this x minus 3 by 2, y minus 4 by minus 3, z minus 5 by 6. So in this second example, the equation of line is given directly in the symmetrical form, and in the first example, in the first format of the example, the point on the line and the direction ratios of the line are given. So we can write if the point on the line and direction ratios of the line are given, then we can write the equation of line as. So this is the point P. Suppose -1 to 5 is the equation of is the point P, and the equation of given line is what? X minus 3 divided by 2, y minus 4 divided by minus 3, and z minus 5 divided by 6. So we have to find the distance of, suppose this is the point and this is the line, and then we have to find the distance of point from line, means we have to find the perpendicular distance of the point from line. That is, draw a perpendicular from point P on the line, and then we have to find this distance. Suppose M is the foot of the perpendicular, then we have to find the distance PM, and it's become a distance of point from line. Okay, so let it be the each ratio is equal to R. Suppose R is equal to this each ratio, and then X is equal to what? 2R plus 3, 2R plus 3, and then Y is what? Minus 9R plus 4, right? Minus 9R plus 4, not minus 9, it is minus 3. So minus 3R plus 4 Y, and Z, after comparing these two, Z is what? 6R plus 5 is the Z. Okay, so the coordinate of general point or any point on the line, on this line, are of this form: 2R plus 3, comma, minus 3R plus 4, comma, 6R plus 5. So this any point on the line has the coordinate of this format: 2R plus 3, right, in round bracket, 2R plus 3, comma, minus 3R plus 4, 6R plus 5. So this is the coordinate of general point on the line, on this line. Okay, now what do I have to find? We have to find the point M, the coordinate of point M. If we have the point of coordinate of point M, then what we have? We have, by using distance formula, the distance between these two. And so what happened? This point M, the direction ratios of line PM, the direction ratios of the line PM are what? If we know the 2 points on the line, then we have the direction ratios of the line. So the coordinate of M is of this form: 2R plus 3, minus 3R plus 4, and this 6R plus 5. And so what are the direction ratios of line PM? So the direction ratios of the line PM are 3 plus 2R minus plus 1, comma, 4 minus 3R minus 2 is the second value of the direction ratios, and comma, this 5 plus 6R minus 5. So these are the direction ratios of the line PM, because the coordinate of PM is of this form. Any point on the line has the coordinate of this form: 2R plus 3, minus 3R plus 4, and 6R plus 5. And so suppose the coordinate of PM are these, then the direction ratios. So if we know the 2 point on the line, then we can write its direction ratios of the line. Okay, so these are the direction ratios of the line PM. And as the line PM is perpendicular to line 1, this line 1, this PM line is perpendicular to this line 1, number 1, and therefore we have, by using perpendicularity condition, A1 A2 plus B1 B2 plus C1 C2 is equal to 0. What are A1 A2 A1 B1 C1? Coordinate of direction ratios of one of the line, and A2 B2 C2 are the direction ratios of the other line. So if the two lines are perpendicular, then we have this A1 A2 plus B1 B2 plus C1 C2 is 0. That is, we have 2R, this calculation is what, 2R plus 4 into 2, because the direction ratio, these are 2R plus 4 comma 2 minus 3R, this is simplification of this, and this is the simplification is what, 6R. So these are the direction ratios of line PM, and the direction ratios of this line are what, 2 minus 3 6. These are the direction ratios of this line. Okay, the line number 1, and therefore we have 4 plus 2R, or 2R plus 4 into 2 plus 2 minus 3R into minus 3 plus 6R into 6 is equal to 0. So after simplification we have this, and then we have R is what, minus 2 by 49. So substitute this value of R in this coordinate general point, that is 2R plus 3. So 2R plus 3, or 3 plus 2R, 3 plus 2 into this minus 4 by 49. Then 4 minus 3R means what, 4 minus minus plus 6 by 49, comma 5 minus 5 plus 6R, 5 plus 6R, but R is minus 2 by 49, so 5 minus 6 into minus 2 become minus 12 by 49, and therefore after simplification we have the coordinate of the point M are what, or in round bracket, right, in round bracket 143 by 49 comma 2, calculation of this 202 divided by 49 comma 233 divided by 49. So this is these are the coordinate of the point M. So now we have to find the distance between the point and line. So the distance of point from the line, that is PM. So what is PM? By using distance formula, the coordinate of P are minus 1 to 5. So minus 1 minus 143 by, so this is negative positive, so right, minus 1 minus 43 by 143 by, right, minus 1 143 by 49 square. Then 2 minus this 2 minus coordinate are what, this 202 divided by 49, 2 minus 202 divided by 49 plus 5 minus this point 233 divided by 49 square, and therefore we have this answer. This subtraction is what, minus 1, here is minus 143 by 49, so 49 is the LCM, so minus 192 bracket square, that is minus 49 minus 143 becomes minus 192 by 49 bracket square, plus 49 into 2 minus 202, it becomes 104 divided by 49. So correction is here, that minus 1 minus 143 divided by 49, right, minus 143 divided by 49 by using distance formula, and this is the calculation, that 49 to 5 minus 233 is 12 by 49 bracket square. And so after calculation we have this, and the answer is root 19.91, that is 4.46. So this is the answer, the distance of the point from the line. Or write this is as a last answer, PM is this, okay, root. So the distance of point from line, how we can find the distance of point from line? first write the coordinate general point coordinate of general point on the line, and then write the direction ratios of the line PM, and then use the condition that PM is perpendicular to given line. Therefore, we have this A1 A2 plus B1 B2 plus C1 C2. By using this condition, find the value of R, and by substituting the value of R in the general coordinate, we have the point, the coordinate of the point M, or foot of perpendicular, and then by distance formula we have the distance between P and M. So next problem is find the distance of this point from this line. Again the same point, same problem, same type problem. So this is for homework or assignment. Find the distance of point from this line. Next is the theorem, find the distance of point x1 y1 z1 from the line x minus alpha by a, y minus beta by b, z minus gamma by c. So in the same line, the proof of this theorem is the same as the answer of this problem. So as a procedure followed in this example, follow in this theorem. That is the same procedure. That is the given equation of this point P. Suppose this x1 y1 z1 is the point P, and the given equation of line is what? X minus alpha by a, y minus beta by b, z minus gamma by c. Suppose it is equal to R, say, then x is equal to alpha plus AR, y is what? Beta plus BR, and z is gamma plus CR. So the coordinate of any point or general point on the line are what? Alpha plus AR, comma, in round bracket, beta plus BR, comma, gamma plus CR. These are the coordinate of any point on the line. Then the direction ratios of line PM are same procedure. The direction ratio. Draw this figure in this example. That right, coordinate of P as x1 y1 z1. Then suppose M is the foot of the perpendicular. Then the direction ratios of PM are what? PM are alpha plus AR minus x1, because the coordinate of the point P are x1 y1 z1. Then comma beta plus BR minus y1, and gamma plus CR minus z1, like this. The coordinate of the direction ratios of the line PM. Here is what? 3 plus 2R minus minus plus 1, like that. So the the direction ratios of PM are this. Okay. As PM is perpendicular to line 1, we have again the condition that A1 A2 plus B1 B2 plus C1 C2. The line PM is perpendicular to line 1, and therefore what we have? We have A1 A2 plus B1 B2 plus C1 C2 is 0. That is A into A. What is A? A means the direction ratios of the ABC are the direction ratios of the line 1. And these alpha plus AR minus x1, beta plus BR minus y1, and gamma plus CR minus z1 are the direction ratios of the line PM. And since the line PM is perpendicular to line 1, we have A into alpha plus AR minus x1 plus B in bracket beta plus BR minus y1 plus C gamma plus CR minus z1 is equal to 0. So by the condition of perpendicularity of two lines. And then after simplification, that is multiply by A, multiply by B, multiply by C, we have this. And then collect the coefficient of R. So what are that? A square plus B square plus C square R. And shift the remaining term to RHS. That is minus AX1 become plus AX1, minus BY1 becomes plus BY1, and minus CZ1 becomes CZ1. And then AR becomes minus AR after shifting A alpha, not AR, A alpha. Then B beta after shifting minus B beta. Then C gamma after shifting it becomes minus C gamma. Okay, this is RHS. Then R is equal to, like the same calculation, that is find the value of R. Collecting the, add the coefficient of R, all coefficient of R, or add the terms of containing R, and remaining terms shift to RHS. And so R is what? AX1 plus BY1 plus CZ1 minus A alpha minus B beta minus C gamma divided by A square plus B square plus C square. And this is the value of R. So R is what? x1 minus alpha after taking a as common, plus b in bracket y1 minus beta, plus c in bracket z1 minus gamma divided by a square plus b square plus c square. And this, therefore, the the distance pm is what? The distance pm is what? The distance of point from line means distance point between point p and m is what? Pm is equal to, by using distance formula, the coordinate of p are these. These are the coordinate of p. That these are the coordinate of p: alpha plus ar, beta plus br, gamma plus cr. And the coordinate of point point p are x1, y1, z1. And so we have by using distance formula, alpha plus ar minus x1 bracket square, like this, the distance between p and m by using distance formula. So the coordinate of p and m are this: alpha plus ar minus x1. X1 is the x coordinate of the point p bracket square, plus beta plus br. Beta plus br, y coordinate of the point m, minus y1 is the y coordinate of point p bracket square, plus gamma plus cr. Gamma plus cr minus z1 bracket square. So write this gamma different than this r notation. Right, gamma plus, this is not r, gamma plus cr minus z1 bracket square, where r is what? R is this. So this is the distance of the point from the line. So this is the theory, that the distance of general have the problem for assignment, that find the distance of point 6 6 minus 1 from the line x minus 2 by 1, y minus 1 by 2, z plus 3 by minus 1. Also find the coordinate of the foot of the perpendicular, that is the coordinate of the point m are the point of foot of perpendicular, coordinate of foot of the perpendicular. So point, these are what? The coordinate of the point m are the coordinate of foot of the perpendicular. So also find the coordinate of the foot of the perpendicular. So the, in the procedure, what? Find the foot of the coordinate of foot of the perpendicular, and then by using distance formula find the distance. So the next topic is angle between line and plane. So in the previous topic, the topic is what? Angle between planes or angle between lines. So in this topic we have to learn angle between line and plane. So we'll see this topic in the next lecture.